Hello dear students, we'll start our lesson. This is lecture 4, the addition theorem and its corollary. Here's the lesson plan for today: the addition theorem and complete group of events, opposite events, corollary of addition theorem, and finally addition theorem for joint events. The addition theorem is as following. The probability of one of two disjoint events occurring no matter what is equal to the sum of the probabilities of these events. For example, what is the probability of getting number 2 or number 3? When you roll a die, number 2, what is the probability of getting number 2? We have to calculate this one. First, probability of getting number 2 is there are only one side in the die with number 2 and total number of wasted, total number of sides of dies is 6, so it's 1 over 6. P of 3 occurring 3 is also similar to this one, and the answer plus 3 becomes P of 2 plus P of 3, which is equal to 1 over 6 plus 1 over 6 equals to 2 over 6, and it's also 1 over 3. And another example, there are 30 balls in the basket, 10 of them red, 5 of them blue, and 15 of them white. Find the probability of a colored ball appearing. Colored ball means red or blue. The appearance of a colored ball means the appearance of either a red or a blue ball. Just now I said about it. The probability of a red ball appearing, let's consider it's as an event A. P of A equals to 10 over 30. In the exercise says 30 balls in the basket, 10 of them red. And 30 balls in the basket, 5 of them blue. So the choosing red ball is 1 over 3, choosing blue ball is 1 over 6. When we add them together, which we need colored ball appearing, we'll get 1 over 2. So total number of balls in the basket is 30, 15 of them white and 15 of them colored. So when you choose any ball from the basket, probability of getting colored ball is 1 over 2, which is also equals to 0.5. Here's next exercise. A shooter shoots at a target divided into 3 areas. This is the target divided into 3 areas. The probability of hitting the first area is 0.45. First area. Let's consider this as a first area. The second is 0.35. The second is 0.35. This is second area. This is second area. 0.35. So we need to find that he will hit either the first or the second area. This is our shooter. He wants to shoot to this target either in the first area or the second area. What is the probability? So event A, the shooter hit the first area, and the B is the shooter hit the second area. Disjoint. Hitting one area excludes hitting another, so the addition theorem is applicable here. So seeking probability is 0.45 plus 0.35, which equals to 0.80. Complete group of events. The sum of the probabilities of events A1, A2, An forming a complete group is equal to 1. Here's an example. The consulting center of the institute receives packages with control works from cities A, B, and C. The probability of receiving a package from city A is 0.7, so the probability of A equals to 0.7. Probability of receiving package from city B, P of B equals to 0.2. Find the probability that the next packet will be received from the city C. So P of C is unknown. According to the theorem just now we saw, which is complete group of events, P of C here equals to 1. So P of A is 0.7 plus 0.2 plus P of C equals to 1. From here I can conclude P of C equals to 1 minus 0.9 equals to 0.1. So this is the packet receiving mailbox. It's 0.1. Here's why it's explained with text. Opposite events. The two only possible events that form a complete group are called opposites. If one of the two opposite events is denoted by A, then the other is usually denoted with this one. For example, when you roll a die, you may get one of 6 outcomes. If we say event A is getting number 5 or 6, the opposite event or the complementary event for the A will be 1, 2, 3, 4 appearing. Hitting and missing when shooting a target are opposite events. If A is a hit the target, then the A with this line is a miss. A board is taken at random from a box. Events appeared standard board and non-standard board appeared are opposite. Opposite event sum equals to 1. The probability the day will be rainy equals to 0.7. Find that the day will be clear. Then will be rainy day and clear day. They are opposite. According to this formula, we can use Q as an opposite event, 1 minus P, 1 minus 0.7, which is 0.3. It means today will be clear with 0.3 probability and it will be rainy with 0.7 probability. The box contains n parts, of which m are standard. Find the probability that among the k randomly extracted parts there is at least one standard. The box contains n parts. It says there is at least one standard part among the extracted parts, and among the parts there is no standard one opposite. At least one standard and no standard. They are opposite event. Let's denote the first event by A and the second by opposite A. Obviously, the probability of event A equals to 1 minus probability of event opposite of event A. So in order to find P of A, which is probability of the event A, at least one standard, first of all we have to calculate the opposite. There is no standard, and then we may find it. It's according to the combination formula. So I want to choose k parts out of n. So I have C and K ways to extract parts from the box. And the number of non-standard parts is equal to n minus m, because there are m standard and total number of parts is equals to m. From this number of parts, we can extract k non-standard parts. K non-standard. So therefore the probability that there are no standard parts among the extracted part is equals to this formula. Using opposite event sum, we can find the second probability, which is P of A equals to 1 minus this formula. And here's the corollary of addition theorem. The probability of the occurrence of one of several pairwise incompatible events. It says like several. In the first theorem, which is addition theorem, we had just 2 events. In this case we have several events. No matter what is equal to the sum of the probabilities of these events. And at last, the addition theorem for the probabilities of joint events. The probability of occurrence of at least one of 2 joint events is equal to the sum of the probabilities of these events without the probability of their joint occurrence. Because they are joint, if we will not find this difference, so it will be a huge number. We will not get the exact probability. Or if we add this number, we'll get another one. So we have to find the difference between the sum of probabilities and their joint appearance. Subtracting their joint appearance. And the theorem can be generalized to an infinite number of joint events. For example, for 3 joint events, we can write as this one. In the cash and clothing lottery, 150 close and 50 cash prize are drawn for every 10,000 tickets. What is the probability of winning regardless of money or closing for the owner of one lottery ticket? So there are 150 tickets with prize, which is given clothes or t-shirts, and 50 cash prize. So total number of prize are 200 here. Or we can calculate the one by one, like winning cash in the lottery 50 over 10,000 and winning clothes in the lottery 150 over 10,000, and we got these probabilities. According to the addition theorem, one can conclude that their sum will be 0.02, which is winning cash or closes. The probability that a shooter will hit 10 points in one shot is 0.1. The probability of hitting 9 points is 0.3. And the probability of hitting 8 or less points is 6. Find the probability that the shooter will hit at least 9 points in one shot. Hitting at least 9 points means hitting 10 points or 9 points. So we have to calculate PFA and PFB, which is the hitting 10 points and hitting 9 points. So if we add them, we will get 0.4. There are 8 standard boards in a box of 10 boards. Find the probability that among the randomly extracted 2 boards, there is at least one standard. At least one in the selected 2 boards means 1 standard board or 2 standard boards. So we have to calculate what is the probability of selecting 1 standard board and then probability of selecting 2 standard boards. And then we can add them together, which will get the exact probability. So good luck guys, see you in the next lecture.